Let's go ahead and take a look at week 10, example 3. In this example, we're given the information that cosine of x is negative 3/5. We're being told that our angle x lives between pi and 3 pi halves, which is somewhere in the third quadrant. And what we're interested in finding is sine, cosine, and tangent of x over 2. So it looks like we're going to use several applications of our half angle formulas here, just like we did in our previous example. This one should be hopefully a little bit simpler for us here. We won't have as many messy square roots within square roots to deal with like we did in our last examples here. So let's go ahead and take a look at sine of x over 2. In the notes, we derived the half angle formula for sine of x over 2 as plus or minus the square root of 1 minus cosine of x over 2. This is great for us. The reason why I'm very excited about this being our formula is because I need to know cosine of x, and that's exactly what was given to me in the problem. One of my only steps I need to take care of on my own before I just do some computation here is decide, should this be a plus or a minus? Let's go ahead and draw our unit circle over here and remind ourselves where we live. Here, we're being told that we're between pi and 3 pi halves. Here's pi, here's 3 pi halves. So it looks like our angle is going to be living somewhere here in the third quadrant. We should recognize that this means that both sine is negative because we've gone down, cosine is negative because we've gone left. Since both sine and cosine should both be negative, we know that tangent then should be positive because we're going to do sine divided by cosine. But we'll get to those signs, positive and negative, in a minute here. In our example here, we're ready to go directly into evaluating. We've just chosen that we're going to be keeping the negative associated with this square root here. And I know the value of cosine of x. It is negative 3/5. Watch it with our minuses here. We are subtracting a negative 3/5. And all we need to do now is do a little bit of evaluation. This one cleans up reasonably nice. I can think of subtracting a negative as addition. So 1 plus 3/5 divided by 2. I'm going to go ahead and think of 1 as 5/5. 5/5 plus 3/5 should be giving me 8/5 that we're dividing by 2. And if I have 8 parts out of 5 and I only keep half of that, I should have 4 parts out of 5. Finally, I don't know the square root of 5, but I do know that the square root of 4 is 2. So I can go ahead and write my answer here as negative 2 over root 5. It's certainly the case that if we are interested in rationalizing our denominator, we would go ahead and multiply by root 5 over root 5, and that would lead us to an answer of negative 2 root 5 divided by 5. Either of those would be our good acceptable answers for this final format here. I'm going to go ahead and save this answer. As we said 1 second ago, we're going to want to compute tangent of x over 2 in a bit here, and it looks like I could use my answers from each of these two parts to help me get there. So I'm going to sort of save my little piece of an answer right here as we proceed through our little chunk of video here. Now, using the same information, we'd like to go ahead and evaluate what is cosine of x over 2. In the notes, we derived the formula for cosine of x over 2, the half angle formula for cosine, to be plus or minus the square root of 1 plus cosine of x over 2. Again, this is great news for us because we already know cosine of x. All we have to do is again make our choice for the plus or minus, which we've already discussed. Since we are interested in a cosine value, we know we're talking about left-right amount, and we can see that our angle of interest is to the left. So I know I'm going to choose negative again, like we did for sine of x over 2. So let's go ahead and evaluate. Negative square root of 1 plus negative 3/5 divided by 2. We'll notice that adding a negative is the same as subtraction. When you take 1 and subtract 3/5, you should land at 2/5. And if I have 2 parts out of 5 and I only keep half of that, then I should have 1 part out of 5. As with the last problem, I can clean this up a little bit. I do know the square root of 1 is 1. I don't know the square root of 5. And again, we could choose to rationalize the denominator here. If I multiply top and bottom by root 5 each, root 5 over root 5, then we should land at negative root 5 divided by 5. Either of those would be our good acceptable answer. I'm going to go ahead and add it to our list of known answers, and then we'll look at two different ways we can go ahead and compute our response for tangent of x over 2. To wrap up week 10, example 3, we need to go ahead and compute tangent of x over 2. There's two different ways that we're going to go about doing this. One way, the directly obvious way, hopefully, is that we would like to use our half angle formula associated with tangent. But we've already done a bunch of work so far that should make this easier for us than even using that formula. We should notice that if we want to compute tangent of x over 2, then we should be able to compute sine of x over 2 divided by cosine of x over 2. Remember that tangent is sine over cosine. As long as all of our angles match, then we can apply the concept of tangent is the same as sine over cosine. Let's do that easy way first, then we'll use the half angle formula for tangent and verify that their responses are the same. Tangent should be the same as sine over cosine as long as all of the angles match, and they do. All of our angles are x over 2. We can use our old responses here to rewrite this as negative 2 over root 5 divided by negative 1 over root 5. This works out pretty conveniently. We have negative divided by a negative, so the negatives are going to cancel. Both of them have denominators of root 5, so those are both going to cancel, and it looks like we're being left with the final answer here of just 2. So that was nice and clean for us right there. Let's go back and use the half angle formula to make sure that we have a little bit of practice and a view at seeing the half angle formula for tangent. We know that we're expecting to see this answer of 2. One other thing I'll say before I step away from this is we knew to expect a positive number here because sine and cosine are both negative in this quadrant, and sine divided by cosine should be a negative divided by a negative. That should leave us with positive responses right there. So let's go ahead and see our other view of this problem. Another way of looking at this is assuming that we hadn't done the previous work to find sine and cosine of x over 2, we would just go directly into a use of our half angle formula here. Our half angle formula that's associated with tangent is plus or minus the square root of 1 minus cosine of x over 1 plus the cosine of x. And once again, I feel pretty fortunate here. We were given cosine information. Cosine keeps cropping up in all of our half angle formulas here. That's going to make this pretty nice for me to go ahead and evaluate. Again, we've already decided that tangent should be taking on positive values when we're within this interval based on our unit circle diagram over here. So I'm going to choose positive. Underneath our square root term here, we should be getting 1 minus negative 3/5 over 1 plus negative 3/5. I'm going to do a little bit of fraction math here on my head a little bit. 1 plus 3/5 should be 8/5. On the bottom, 1 minus 3/5 should be 2/5. And I'm going to see here that when we have fractions divided by fractions where the denominators are the same, they cancel. So 5 and 5 are going to cancel, really leaving us with just 8 over 2. That's good for us. I know that 8 over 2 is 4, and the square root of 4 is 2, exactly like we arrived at from our previous method here. So notice that we can go ahead and use our sine and cosine information to get tangent, or use tangent's own formula. Finally, before I end this video, I'd really like to point out, I hope you guys have been kind of watching my eyes as I go through these videos here. I keep on having to glance down at my paper too, to keep on referencing what my formulas and identities are. In this one, for example, I kind of remember this format, but I keep on forgetting which one gets the plus, which one gets the minus. Keep in mind that you should have your full identity sheet with you, either that PDF that's posted in Canvas or just keep it open the very back of your book. You should be constantly looking up these formulas. Remember that you're never going to be expected to memorize these formulas, especially now that the rest of this class is not going to be in person. So keep this formula sheet handy with you so that you can look these things up as easily as you need.